further north. In fact, we're talking about space, as I mentioned. Did you know that weather changes do happen in outer space? Well, it's true. And now a new solar camera developed to detect those changes started being used just this year. I talked with one of the experts to find out just how it all works.
What you're looking at is a solar mass eruption coming from the sun, seen like it's never been seen before. It's coming from a new camera first launched into space just last year, helping us learn more about weather in our own galaxy.
We designed and built SoloHigh, which is a very specialized camera to take pictures of the solar atmosphere at very far distances from the sun.
SoloHigh stands for Solar Orbiter Heliospheric Imager. The camera watches the solar wind, dust, and cosmic rays that fill the space between the sun and the planets.
We're trying to be able to predict the weather in space the same way we would do it here on Earth.
And they do it in a very interesting way.
We don't actually look at the sun, we're actually looking off to the side of the sun at this incredibly diffuse plasma, which is 10 to 12 orders of magnitude dimmer than the sun itself.
But even the smallest amount of material can make a huge impact on the weather in space.
So there's this constant outflow of material from the sun. And then sometimes you get what are almost equivalent to hurricanes in that space, where you have this huge explosion of material and magnetic field that leaves the sun and goes out into space. And that's what we captured in our images, is one of these coronal mass ejections.
And space weather phenomena such as this are quite special to watch too.
And actually, we've been observing these since the 70s when the phenomenon was first observed. But this is the first time that we were able to take it with this particular instrument. So this is the first observation of a coronal mass ejection that we made with the SoloHigh imager. And what's special about this is we're actually much closer to the sun than we are from Earth. So we're about 30% closer to the sun than we are at Earth. So it's very interesting to be actually in this weather system and taking a picture of it.
What is the whole purpose of using this camera to capture something like this?
So the purpose is twofold, but one is just from a purely physics standpoint. You know, this is an incredible regime that you're looking at, because you're looking at this plasma at densities that you just don't exist on the Earth. And then the second is a very practical reason. As I said, this is very analogous to weather on the Earth, and there is weather in space, and that can affect human systems on Earth. So it can cause satellites to black out. It can cause disruptions in the power grid here on Earth, and be a threat to any assets that we have in space, including astronauts in space. So these kind of things, we want to be able to predict the weather in space the same way we predict the weather on Earth.
And the big question now is what happens with all of that information that they're looking at when it comes to weather in space? It's actually sent to NOAA, who puts out a space weather forecast for commercial satellite users, aircraft, and other industries that can be affected by the weather in space. And it even goes to people like Adam to help you determine what your weather is going to be and our weather is going to be here on Earth. What do you think? I told her you're going to love this.
Yeah, no, it's such a cool package. I was just sitting here like looking at the TV right next to me, like very interesting stuff right there. I love the imagery too. And now I'm thinking, do we need like a space weather kind of forecast hit once an hour or something? We got our tropics, we got our Texas, we do space weather maybe. All right, let's start with